Hello everyone, here's another video showing off the external buffer I built for the Palette 2. You might already have seen the time-lapse I made, but it was on a different print at a lower speed, and since it was a time-lapse with like 1 picture per second or something, it was a bit hard to see how the buffer was actually doing. Many of the buffer depletions, it was a lower speed, it was not very deep, and record quickly, so they often happen between frames in that time lapse. So if I make a video that is running in real time, and with a test object that have much bigger surface where I can get much higher speeds. So here I'm printing at 200 millimeter per second with a 3000 millimeter per second acceleration. So it is running most of the time at actual 200 millimeter per second. The total average from if you take like the time to make a full layer, including the purge block and everything, and travels and all, and divide that by the total length of plastic laid down, it turns out to about 160 millimeters per second. So, because it of course has to retard and accelerate between each of the stretches. So like here on the close to the corners on the purge block, the effective speed is of course a bit lower, but a good portion of the print is actually running at the 200 millimeters per second. And as you can see here, it just had its first low buffer situation where it drained the internal buffer and had to rely on the external one. The reason for making the external buffer was of course that the internal buffer on the Palette 2 is way too small to get any utilization of the splice core, which is really sad. I mean, it takes about 40 seconds with the default PLA profile to splice the filament, and the internal buffer is so small that if you have like I on purpose made this print with two big sections and one small, so that so you get a big difference between the time it takes to deplete each of the three colors. So we have two colors that take a long time and then one that take a very short time, and that means that you need a buffer that is big enough to average this out over the full layer, and the internal buffer is nowhere near big enough to do that. And it also have a major design flaw in the buffer level detection system. So they have a switch in there that will detect when the buffer is empty, and but they have no switch that detects when it's full or near full. So for them to calibrate the scroll wheel that detects how much goes out versus the input drive, or the output drive they call it, the one that pushes filament into the buffer. Since they aren't 100% in calibration, you risk having the buffer drift towards either empty or full. So every now and then they need to recalibrate the system so that they know exactly how much have gone out of the buffer versus how much have gone into it. The way they do that is to periodically drain the buffer down until it hit the buffer empty switch, and then they know that okay, now it's empty, and then they fill it up to about 50% and keep it there. So, but the problem with that is of course that since they have to drain it down every now and then, if the splices are coming very close, it actually sometimes fail to plan it good enough. So they will do one of these pongs that they call it, where they drain it down and hit the buffer, they will start one of those too close to a splice, and then you will end up having a failed print because it drains the buffer and then it starts to fill it up, but before it's gotten back to the regular 50% full, it will start a splice and start depleting again, and then you risk having a run out. And even when it is running normal, it is not utilizing the full buffer. It's around 50%. So the buffer is already way too small the way it is. And then they have this calibration system that don't allow them to use all of it. So the internal buffer is kind of useless. So that's why it works if you print very slow, very slow. But any kind of normal speeds will cause you to have failed prints every now and then. So and also in multi-spool mode, this design makes that non-implementable, because it have to drain the buffer every now and then, and it can't know in advance when a spool will run out. So you always have the risk of having a spool run out right as it has depleted the buffer, and then it's just screwed. So my external buffer completely solves that problem, because you always have the external buffer to take care of the splice when you're switching from one spool to another. Unfortunately, there is another hardware bug in this thing that makes multi-spool not work, so I'll come into that later in another video. So, but anyway, here you see the external buffer in action. There is no way you could have printed at this speed without the buffer, but here it runs just fine. This test was actually meant to just show that it prevents starving the printer, because what would happen in all this, like now, when it just ran out, if the external buffer hadn't been there, it would now starve the printer, so the extruder in the printer would either just snap the filament or start grinding. Either way, it would fail the print. But because of the external buffer, it can just keep going. When I was printing as fast as I'm doing now, I did not expect it to stay in calibration, because for that to work properly, when you have deep buffer depletions, it kind of needs some support from the firmware, which I was kind of hoping that the Mosaic would implement, or make some changes to the firmware that would allow such a buffer to work. But yeah, the word I've gotten from them is that such a buffer can't work, and that I have explained it in detail why it can't work. So I haven't seen that explanation, but I claim that it exists. So yeah, I kind of doubt that they will do anything to help out here, but it would be nice, because first of all, the pings they are sending, the way they're calibrating is that they insert points in the G code where the printer will signal the palette that I'm now at this and this point in the G code, and then the palette will compare the palette will compare that with what it expects the printer to have spent of filament, and then adjust its following splice length to compensate for any discrepancy there. One issue is that it seems to be sending one ping per layer, or about one ping per transition. So every time it goes to the purge tower, it will send a ping. But I have seen cases where it doesn't do it, so maybe if the transaction comes too quick, it will skip it, or I'm not exactly sure how the rules are there. But anyway, it's about once per transition, and it sends the ping while it is on the purge tower. So I'm not sure why they do it so rarely, because I've had prints fail because you have early in the print some very long single color areas where it actually get auto calibration enough to fail before it gets the first ping. Because on this print bed I can fit about 7 meters of filament, and that is long enough for it to drift off far enough that it will fail. So I'm surprised why they're doing it so rarely, and I would think with this system, I can understand it with the old system where they pings are done by doing pauses over the purge tower that the pallet would then detect and know that okay, we're at this point, it will check it. But when you have the hub in between where pinging is done digitally, I would think that it could be pinging at much higher frequency. So what could make the buffer much more usable is if they were basically sending pings very, very frequently, and then just ignore every ping that happened while the buffer was depleted. And they can know when that happens, because that is when the buffer empty switch is pressed, so that they can detect that their internal buffer is drained, and then there is no point for them to care about the pings that happens then anyway. So it won't change the normal operation, because if you don't have the external buffer and that condition happens, okay, then the print is failed, so no one cares what it does after that. If the external buffer is there, it will it could be used as a signal to the firmware to just ignore any pings, because there is no correlation between the amount of filament that has passed the scroll wheel and the amount of filament that the printer has actually used. So, but then when the buffer recovers and the switch is released, then they can start looking for pings again. So then it should be possible to print at upwards of 300 millimeter per second with this system and stay in calibration and not run out. So we'll see. It would be nice to have that implemented. But anyway, you can see it works very well. And yeah, I was like I said, not expecting this print to stay in calibration, because it is printing fast enough to deeply deplete the buffer many times during the print. But amazingly enough, it did stay in calibration, so that actually puzzles me a bit. I was first printing this with 130mm transitions, and I was expecting just to demonstrate that it didn't fail the print, like it didn't run out and started grinding. I expected it to be completely out of calibration, but that 130mm transition was almost enough. So it had some bleeding on one of the layers, in one of the transitions. Otherwise it was fine. So I increased it to 150mm, and that's what you see now. And this print, there was one very close call where it almost ran out, but it didn't. It stayed in calibration. The transition happened on the purge tower, and the rest of them was very good. So it stayed very well in calibration during the whole print, except for that one case where it was almost running out of black. You can see it was just a tiny corner that was black on the tower before it switched to the next color. So but I'm very happy with this. But if you print at lower speeds, like upwards of like around 100mm seems to be the sweet spot, where it only briefly touches the buffer, and it rarely have a ping going off as it happens. So and that's still like at least a doubling of the safe speed you can normally run this on, without risking having some model actually cause the buffer underrun. So I'm pretty happy with the results. But anyway, I'll just leave this running. It's about halfway now, I guess. So if you want to see to the end, you could do, or you could just close it now. There is not much more to see. It will complete this print, and it stays in calibration the whole time, and the print succeeds. So that was a great success. So see you later.